Our topic in this video is deductive logical reasoning, which is basically the process of taking one or more statements and using them to form a logical or come to a logical conclusion. So we've got three patterns that we need to be able to apply to these statements. Now, while you don't need to remember the names of the patterns, you do need to be able to determine whether or not something is creating a valid conclusion based on statements that you have. And I find it does help me to know what the patterns are so I can use them for comparison. So our first pattern is called the law of detachment. And again, really the only thing that we need to remember is the pattern of how statements show up and how we can come to a conclusion based on those. So our pattern in symbols starts with the statement if P then Q, so conditional statement. And then our second line is just P. So what this is going to look like is repeating the idea from the hypothesis of that conditional statement that we were given. And then we have three little dots, which if you remember from the beginning of the unit when we were talking about our symbol versions of different words, this really stands for therefore. And so symbolically, we can put this in front of the conclusion that we've come to based on our previous statements. So if P then Q, and then we're given P, therefore we can conclude Q. And it's pretty much just repeating the ideas. If P then Q, P, therefore Q. So let's look at this with an actual statement to put this into words, because I know the symbols are looking a little weird. This is definitely something different that you haven't seen before. So our example is, if you skip school, then you'll be grounded. So that's our if P then Q, that's our conditional statement that we're starting with. You skip school. Well, that idea, maybe not that exact grammar, but you skip school is exactly what showed up in the hypothesis of that conditional statement. So that's exactly what we had for our P statement. So if we're following the pattern, if you skip school, then you'll be grounded. You skip school. Therefore, what happens? Unfortunately, you get grounded. So we would have, therefore, you'll be grounded. So that statement logically follows from the first two sentences we were given. So remember, law of detachment is really just repeating the ideas over in order. So law of contrapositive, well, that word probably sounds really familiar. So don't forget, when we had contrapositive statements, we went from having, for example, if P then Q, our contrapositive was if not Q, then not P. And that's exactly the same order as this law happens in. So if we're given a statement, if P then Q, and then they give us the statement, not Q, we can conclude not P to kind of finish that order with making a contrapositive statement. So using the same ideas, we start with, if you skip school, then you'll be grounded. Again, if P then Q. Conditional statement to start with. You don't get grounded. So that's the opposite of that Q statement. So a not Q, the opposite of that second idea we had in our conditional statement. So if we follow the pattern, then we'd be able to, let me scooch this up, then we'd be able to conclude that therefore you didn't skip school. So if you skip school, then you'll be grounded. You don't get grounded, therefore you must not have skipped school in the first place to get in trouble. Okay, so law of contrapositive, again, it follows the same pattern as just writing a contrapositive statement. It's just kind of separating it out into steps. So then our third law that we're going to practice today is law of syllogism. Now this sounds a little bit weird, but this is actually very similar to something that you've already done in algebra. So do you remember the transitive property? So transitive property in algebra was if A equals B and B equals C, then A equals C. So you're kind of transversing the statements and returning what's at the beginning and the end of those two sentences. So in symbols, we would start with our same, here's our conditional statement, if P then Q, and then we're given another conditional statement, if Q then R, where you notice you've got the Q's repeated, you've got the idea repeated in between those two sentences. So our conclusion, therefore, and I'm not sure why I have parentheses around that, but that's okay. So therefore, we can conclude if P then R, taking the first sentence or first idea and the last idea from those two statements. Again, let's apply this to actual sentences to see how it makes sense. So if you skip school, then you're grounded, or you'll be grounded. If you're grounded, then you can't go out with your friends. So therefore, let me scooch this up. So therefore, capital T, let me fix that. So therefore, if you skip school, then very last idea, you can't go out with friends. So if you skip school, you'll be grounded. If you're grounded, you can't go out with friends. We have that overlap sitting in the middle. So we're going to conclude the first and the last ideas that were on the front and the back of those two sentences. So let's look at a couple more examples, and then we'll practice looking at how you can tell the difference or trying to pick out which ones are valid versus invalid conclusions. So again, let's do another detachment example. So if you were able to watch that Monty Python video, this is where I'm getting these statements from. But again, you don't need to know that. All we're worried about is, can we follow the pattern? That's all we care about. So our detachment example, you notice I've given you two statements and then we're going to write down the conclusion. So if she has a long nose and a wart, then she is a witch. So we're going to identify which pieces, and this is where translating this back into symbols is extremely helpful. If she has a long nose and a wart, that entire piece is our hypothesis. She is a witch. There's our conclusion for a conditional statement. So I could write this as if P, then Q. She has a long nose and a wart. Well, that's a repeat of that first idea. That's a repeat of our P statement. And so we're starting to make that detachment pattern. If P, then Q, P, therefore Q. So that means we can return what that Q statement was going to be. So therefore Q. And so I'm just going to copy that from that first sentence, but I am going to put a therefore in front of it, just so it's identifying, here's my conclusion. So therefore, she is a witch. Alrighty, so again, repeating the idea for detachments. Contrapositive, we're really just writing our contrapositive statement over again. So if she is a witch, then she turns people into newts. So again, let's identify hypothesis and conclusion. So in this one, if she is a witch, that's going to be what we'll count as our hypothesis, our P. Then she turns people into newts. So let's call that our Q statement. So if P, then Q. And again, you could use any variables you want. I tend to use P's, Q's, and R's just because I know I'm not going to use them for anything else. We use X's and Y's when we graph. We use A's, B's, and C's a lot of times in algebraic properties. So I tend to use P's, Q's, and R's when I'm doing logic. Okay. Second statement, he's not a newt. Well, that's the closest to that second statement. So we labeled Q as she turns people into newts. So he's not a newt. That's pretty much the opposite of that Q statement. So that guy is not Q. And so again, it's almost as if we're starting to write our contrapositive statement. So therefore, we would want to finish with not P, and that would finish our contrapositive order. So therefore, she is not, because again, it's a not P, so we have to put the not idea in there, a witch. And again, when you're thinking about these sentences and writing them out, and I would absolutely suggest writing out your examples as you're trying to figure these out, I'm not so worried about the grammar. Okay. If you're going to have to write statements out for anything, it's all about, do you have the ideas in the correct order? Do you have your if and your then in the correct spot? Grammar doesn't matter so much for this class. This is not English class. I'm not testing your grammar. I'm testing, can you put the ideas in the correct order? Okay, third example, let's go and look at syllogism. So again, syllogism is a little bit different in that we've got 3 ideas that we're working with. It's the only one that has 3 ideas to it. So that could be a good thing to think of when you're trying to figure out, hey, does it follow one of my patterns? So if it is made of wood, so let's call that our hypothesis P, then it floats on water. Let's call that our conclusion Q. If P, then Q. Our second sentence uses that Q idea again. So I'm going to circle it, use the same symbols. I know there's not a lot of room to label, so I'm just going to circle it. But I know I'm starting with Q. It weighs the same as a duck. Totally new idea, so I'm going to give it a totally new variable. So let's put kind of a bracket around this one. So it weighs the same as a duck. We're going to call that R. So our first 2 statements are if P, then Q, and then if Q, then R. And so our syllogism example, again, just like transitive property, you've got kind of those middle 2 statements that pretty much when you're writing your conclusion, you're just going to ignore them. So if I ignore those, then that means I'm left with, therefore, if P, then R. And I'm just going to fill in the ideas that we already labeled with the P and the R from our previous statements. So therefore, if it is made of wood, and I'm going to abbreviate a little bit because I know there's not a whole lot of space, then it weighs the same as, I'm just going to write equals duck, because the same idea, weighs the same as is equal to the weight of the duck. So again, syllogism, just like transitive property, we're just writing it out in words instead of using variables. Okay, so let's look at some examples. And again, if you need to, pause, go back, rewind, rewatch those examples if you need to. That's why I'm posting videos the way I am. So you can go back and watch these as many times as you want. You can slow me down, you can pause as you need to. Okay, here we go. First set of examples, I give you everything. So I give you 2 statements and I give you a conclusion. And when you see these types of problems, always think that third statement is your conclusion. Does it follow from the first 2? So first example, if a hurricane is category 5, then the winds are greater than 155 miles per hour. Okay, so I'm going to label this guy as if P, then Q. And again, if it helps, let's go ahead, underline for the P, circle for the Q. Okay, if the winds are greater than 155, well, wait a second. That's the same idea that we just labeled as Q, so I'm going to circle them. Then tree branches fall down. New idea. Let's give them a new symbol, and I'm going to use the bracket. So we are given if Q, then R. So what pattern, what law do you think we're actually using on this one? So hopefully you notice, hey, I have 3 variables. I have 3 separate ideas. So I want to check that against law of syllogism, and it's in the perfect order. I've got my Q's kind of lined up. So that means, therefore, I should have if P, then R. So let's double check that. Do I have that in my third sentence? So if a category, or if a hurricane is category 5, it's exactly what we had in our P statement. Then tree branches fall down. That's exactly what we had in our Q statement. So this is definitely a valid argument. They used the correct pattern. So we can label this as valid. And again, it doesn't matter so much if you can identify the name of the law, but if you can figure out that, hey, that fits one of my patterns so I can use it, that's what you need to be able to do. Okay, next problem. Here we go. If the street is flooded, then you'll need a boat to get to school. Your street is flooded. You can go fishing. So again, statement 3 should be your conclusion. And I'm noticing statement 2 doesn't have an if then. So right off the bat, if I'm thinking about my patterns, well, law of detachment and law of contrapositive, neither one of them had that if then, neither one of them had a conditional statement in that second idea. So those are the patterns I want to go back and look at. So again, let's try mapping it out. So if the street is flooded, that can be our P statement. You'll need a boat to get to school. a new idea. So let's call that Q. Your street is flooded. Well, wait a second. That's the same idea. Again, the grammar's a little different, but it's the same idea as what we used in that P statement. So it almost looks as I'm just repeating that sentence over again. So my conclusion should be, therefore Q, and you can go fishing. Wait a second. Do we have you can go fishing anywhere else in any of these sentences? Huh. That's a totally new idea. So if I was going to label that with variables, I'd label that as R, and we don't have a pattern that matches up with that. It looked like it was getting really close to that law of detachment where we go PQ, PQ, but it just didn't line up. So unfortunately for this one, this is invalid. It's almost law of detachment, but it threw one too many ideas in there to actually match that pattern. Alrighty. Example C. Okay, if a point is in the middle of a segment, then it is a midpoint. This is actually a definition that we're going to use next unit. But again, we don't have to worry so much about do we know what these statements truly mean. We're only looking at what's the order that they're written in. So that's all we care about. Okay, so if a point is in the middle of a segment, there's our P, then it is a midpoint, there's our Q. So if P, then Q. Okay, a point is not a midpoint. What does that sort of sound like? Well, it's pretty close to that second statement, it is a midpoint. So I'm going to say that that's a version of that one, which would be, it does have that not thrown in there. So I'm going to call that not Q, opposite of the previous statement. So then if this is following, let's see, what law do you think this is going with? It's almost the beginning of that law of contrapositive. So I would expect to have not P as my last sentence. And if I read that, if the point, or excuse me, the point is not in the middle of the segment, again, we have that word not in there. So again, this is really close to the P statement, except it had an extra not thrown in there. So this is actually a not P statement. So that absolutely follows our contrapositive law. So this is a, let's see, let me change my color. So this is a valid conclusion. Again, you're just trying to find where is it that we have, or do we have that extra pattern? Okay, there we go. Okay, last example in the set. If the window is left open, then bugs will get in the room. Bugs aren't in the room. The window wasn't left open. So if if the third statement is supposed to be our therefore our conclusion. Okay, let's check the first two statements. So if the window is left open, so the window is left open, that can be our P statement. Bugs will get in the room, that can be our Q statement. Okay, so statement number 2, bugs aren't in the room. Huh, okay. Wait a second. That's the opposite of that Q statement again. So that's our kind of aren't in the room. So that's a not Q. So what's happening on this one? So it looks like it's another contrapositive statement being rewritten. So the window wasn't left open. It was not left open. So that with the wasn't, that is definitely a not Q, excuse me, a not P. And it's yet another one that follows that law of contrapositive pattern. So this one is indeed valid. Okay, so again, pause if you need to rewatch the section before we go on to the next one. Alrighty, so second set of examples, you'll notice I left off the conclusion. So in this set, we're trying to figure out, are they starting us out correctly, and can I actually come to a logical conclusion based on those two ideas? So first one, if it does not rain, then I will walk to school. So that would basically be if P, then Q. So if P, then Q. It didn't rain. So again, ignoring your grammar, but still looking for any positive or negative types of words. It didn't rain. Well, that's pretty much that same first idea. That's P. So what does it look like we're trying to write? Yeah, it looks like it's starting that law of detachment order. So we are going to make a conclusion. If we finish our idea, that means we're going to do therefore Q. So our conclusion can be therefore I will walk to school. Alrighty. Next one, if it does not rain, then I will walk to school. If I walk to school, then I'll wear my hiking boots. Now I'm noticing a repeated idea in the middle. Let's map them out. And let me put a little line through this so my work doesn't kind of interact. Okay, if it doesn't rain, okay, we can call that our P statement. Then I will walk to school, Q statement. Hey, it's the same conditional statement even that we started on the previous problem. That's okay. If I walk to school, that's a repeat. There's my Q idea again. So that's if Q. And then I'll wear my hiking boots. Wait a second. Totally new idea. So let's give them a new variable. Let's call them R. So if we have that repeated idea in the middle, the Q's repeat, what can we then come to a conclusion on? So again, if we have those repeated Q's in the middle, then that means, and I'm going to write this over off the side a little bit, that means we can conclude just the leftovers if P then R. So if I write that out, I can say, therefore, if it doesn't rain, then I'll wear my hiking boots. Wear hiking boots. Maybe you have really nice hiking boots that you don't want to get the leather wet on them. Okay. Next one, if you practice and study for the test, you should pass. Again, long idea for the first part of that sentence, but it's still all one idea. So you practice and study for the test, you should pass. Now it doesn't have the then in there, but it's implied. You could put that in there and it does not play around with the grammar or change the idea. So I could read this as, if you practice and study for the test, then you should pass. And it means exactly the same thing as the sentence they gave us. So there's our if P then Q. You passed the test. Wait a second. That's a repeat of that second idea, isn't it? So that's repeating Q. Wait a second. We don't have a pattern that repeats just the plain old Q. It's close to contrapositive, but we would have to have the not, the negation in there. So unfortunately, that means I can't make a conclusion on this. We're going to call this one, let me change my color, invalid. Okay, now would be a great time to pause the video, try out example D on your own, and then start it back up and see if you got it correct. All right, so let's check your answer for part D. If you eat a good breakfast, then you won't be hungry till lunch. So again, you eat a good breakfast, you won't be hungry till lunch. If P, then Q. Okay, you were very hungry after first block. So it's kind of introducing that idea of first block, but think about how it relates to the previous statements. If we said originally our Q statement was, you won't be hungry till lunch, but then you were really hungry after first block, and you don't get a break for lunch until in between second and third, or if you're in person, third block. So that's definitely kind of the opposite idea of what they put in that first sentence. So I would call that kind of the negation of that idea. I would call that a not Q. And so wait a second. Looks like we're starting to write our contrapositive. So our conclusion on this one would be therefore not P. So we can write the conclusion out in words. So therefore, you didn't eat a good breakfast. Maybe you didn't have enough protein to hold you over. Alrighty. So we're going to play with these ideas more in our next video, but right now I just want you to practice getting the order of the different laws down. And again, you're not going to need to necessarily name what order is being applied, but you do need to be able to state whether or not you have a valid or invalid conclusion. And you do need to be able to make a conclusion if you're given the first two sentences. So again, we're going to practice this again next class. So we'll have some additional examples that we'll do in our next video with how we might apply these to other sentences. So see you later. Again, don't forget to ask me if you have questions.